So Jakub mentioned something which I think is very interesting, this transition between from the academic kind of machine learning to machine learning in the real world. And one of the big differences that happens is when you're in an academic setting, oftentimes you're optimizing for your test set, right? So you have your training, you have your model, you have a training data set, you have a test set, you're optimizing for the test set. And one of the things that we've noticed is that when you go to the real world, oftentimes that's not enough. What happens is you could have a model that's doing great on the training data, even great on the test data, but when you actually deploy it, so I'm talking about it maybe at a little bit of a later stage than what Jakub mentioned. When you actually deploy it, models tend to fail all the time in costly ways for companies, in maybe embarrassing ways, bad PR, if the model has been deployed externally, and sometimes even in silent ways. So the model is making bad predictions, but you don't even realize that. So why does this happen? Essentially, the reason it happens is because your real world data doesn't look like your test data. Or in other words, you've been optimizing this entire time for your test set, but you haven't been optimizing for real world data. And that's natural because I think most of the time as machine learning scientists, we focus on the test set because that's what we have. Someone has given us data, so that's what we're optimizing for. But we think that's actually a bad paradigm because it leads to all of these problems that I just mentioned. What would be far better is if you were optimizing for real world performance. You deployed a model as quickly as possible, and then you got feedback on how the model is doing in realistic settings, and then you adapt your model appropriately. And so this is one big motivation for why we built Gradio, because we wanted to make that process for deployment and putting your model in the hands of a domain expert, whether that's in the medical setting or it's in the business setting, or there's lots of different use cases here. Sometimes applied scientists are the ones that are using these interfaces. Get them using your model and giving you feedback on, hey, the model isn't working here, the model is working where. And we've seen this now in so many different settings. This feedback leads to a lot more robust models, which end up getting trusted as well by a lot more by your interdisciplinary team. Because what ends up happening is oftentimes, like as machine learning scientists, we're the producers of these models, but there's someone else that's the consumer. And when we're working in isolation and we're working in these silos, oftentimes when we ship out this product, there's no reason inherently for someone to trust it. Like, we're just giving them a tool, but why would they trust it? And as soon as the model makes a very embarrassing mistake or something that no human would do, then you're like, oh, then the people who are supposed to be using this model, okay, I'm not trusting this anymore. I would never make such a mistake. Why would I trust it? That's why I think it's very important, and we're seeing this in a lot of different spaces, everything from like clinical trials to business teams. Now, trying to use the model even before it's deployed, so that they can give feedback on the model and make sure it's something that actually works. And that ends up leading to, I think, this kind of collaboration, which is maybe, I think, at a later stage than what Jakub is saying now, when you want feedback, not from necessarily from machine learning scientists, but maybe from the actual users who are going to be using your model. And that ends up leading to models that are actually more robust and more trusted by the people that should be using them.